Year 9 Trigonometry Exam Practice Question 1. A ladder rests against a brick wall as shown in the diagram. The wall of the ladder is 1.5 meters from the wall and the top reaches 3.5 meters up the wall. Find the length of the ladder correct to one decimal place. So this is where we are going to use Pythagoras theorem. And we know Pythagoras theorem is a squared plus b squared equal to c squared. So we know that these sides we have are the shorter sides, which is our a and b. So we've got 1.5 squared plus 3.5 squared, and it's equal to c squared. So 1.5 squared is 2.25. And 3.5 squared is 12.25. And that equals our lovely c squared. So the next thing that we need to think about is adding them together. So 12.25 plus 2.25 is equal to 14.5. So now we've got 14.5 is equal to c squared. So now we need to get c by itself. To do that, we need to square root both sides. So we're getting square root of 4.5 is equal to our ladder length of c. So the square root of 14.5 is equal, I'm going to write it in the whole number, and then we will round it to one decimal place. So 3.807, because I need to round it, it's got a 0 in the hundreds, and so I can just cancel it and round it down to 3.8. So I know my hypotenuse, my ladder, is 3.8 meters. Let's look at the second part now. It says find the angle between the ladder and the horizontal. So we're talking about this part here. Now, because we rounded that, I'm just going to use my two short sides and use the rule of tangent. Tangent alpha is equal to opposite over adjacent. I know this side over here is opposite my angle, and I know this side here is adjacent to my angle, next to the angle. So I'm just going to put the information in, which is tan alpha equals opposite, which is 3.5 over 1.5. Now to get my alpha, my angle by itself, I need to do the inverse of tan. The inverse of tan is tan negative 1 and timesing by 3.5 divided by 1.5. And this is where we do need the calculator for some of the things in maths. But that does give us the angle of 66.8. So 66.8 degrees. And that is our angle.